As a developer that's trying to become more single, you have to eventually learn how to communicate technically and communicate system design technically or system architecture technically. So what I'm going to do right now is I have this mobile app that I built, and it has a system behind it or a service behind it, a cloud service behind it. And what I want to do is draw to explain the architecture or the system design behind this app that I built. So what I do to do that, or at least I'm going to show what the app looks like first and how it works. So this is Snapita, a mobile app that I built that allows you basically to copy snippets of text, save snippets of text, and quickly copy them to paste it to your clipboard. And then you can create like lists and of different snippets that you have, and then you can search the snippets. And how it's set up is it has a on-device component and it has a cloud component. So some of these snippets are stored to the cloud. Like I store all my social media hashtags in here, so I can quickly go grab them when I need them to do a post. And I have a bunch of like random snippets and stuff. And then you have the on-device snippets. So if you decide that you don't want to store any snippets in the class, you can in the cloud you can just store them directly on the device itself. And so that means this cloud portion, I mean, the on-device part is just on the device. It's built into the mobile app itself. The cloud portion needs to actually go through the internet to some sort of service and then actually get stored in some sort of database. And so this is the part where the architecture diagram comes in to kind of describe how the system will work at a high level. Let's draw this out. So I'm gonna move this over here. And what I like to use is Excel-a-Draw, but there's plenty of diagramming tools you can use. There's some better than this, some more closely knitted to system design, and some that are less directly tied to system design. But this one is pretty cool. So the first thing I'll draw is just a little mobile app here. So we can call this mobile app. And so inside this block is gonna literally be everything that happens with the mobile app. This is like the logic inside a mobile app that I would create. I would go create this with native iOS code or Swift code, or I would go and use React Native, like a cross-platform framework, and write the app there. But everything that the app does and app shows will be inside this block. So you could go a step deeper and show the architecture of this, but right now we're kind of at a high level architecture where I want to show kind of how the whole system works. And so this app needs to make requests, like I said, like saving snippets. If a person adds a new snippet to the cloud, if a person signs up for the app, they need to be able to hit the cloud and hit the database and be able to store that. So we know at the end of the day that we have a database. So let's draw that out here. And eventually we know that like the snippets are getting eventually stored here. But how do they get here? And where do we put this database? And so I can draw a bigger block to basically say, let's say we want to do all of our service hosting on a cloud provider like AWS. So we can just say AWS, like this is the AWS environment, and this is where our whole cloud service is going to sit in. This app itself is just going to sit outside because it's installed like on Apple's App Store, on Android App Store. But our system, kind of our backend basically, is all going to be hosted in with a cloud architecture hosting provider like AWS or GCP, Google Cloud Platform, one or the other. So we know the database that sits here. The other thing that we want is we need to have what's called a web API, and that's application programming interface. So that's some sort of interface that we can use. I'm gonna draw an arrow between these two that we can use to, I'm gonna draw an arrow kind of back from here a little bit too. Maybe put it after. And so we need a way for the app to be able to communicate with this backend. And so web API is an interface where you can make what are called web requests, or they're sometimes called REST requests if the REST protocol is used. But yeah, and so there, I'm just gonna put REST, web REST request, and I'm gonna put some examples here. Like we're gonna have like sign up endpoint, we're gonna have new snippet endpoint, edit snippet endpoint, delete snippet endpoint. And so these will be REST calls that we would make. And so basically what a REST interface would be a URL that gets served over the internet. So this might be www.app.com API sign up. So this would actually be served over the internet, and my app would make basically a REST request or web request similar to how a browser downloads a web page. And it would make that call to sign up, and it sometimes would need to send data with that call in some sort of format. Typically that's JSON, which we can discuss that, which is like a format used to share data between applications. And so you need to send that data, like on the sign up, for example, you would send the password, the username, the email, the phone number, whatever is used to sign up an account. And if there's an error, it would send back some sort of error code or error message. It would return that. Or if it was success, it may return back success and whatever the user's new ID is. For new snippets, it's a similar process. Like when they want, the app needs to add a new snippet to the system, it will make a new snippet request, and it would send the data needed for a new snippet. And the web API would decide whether or not this request was good and whether it could store it. If there was any issues, it would report back, or it should report back. And so that's basically how the web API step works. So in my app, that's actually a PHP web API that I built. So yeah, that's how the web API works. But it actually needs to access a database to be able to save and store the data. And so what we can do is we can actually draw an arrow here and sort of an arrow back from here that kind of gives feedback on what happened with the database. And so here I would be storing snippets and of course users. And so whenever these API gets hit, these pages, basically the API is sort of a manager of getting requests from the app, figuring out what those requests are, validating them, and then converting them into some database storage or database read. So also if I need to get the snippets, it's also here as well. So like, let's say I need to just get snippets or whatever, just read from the database, then that's also a request that could be made on the API. And then it will make a request using like SQL, which I can maybe write SQL query here, make a SQL query to basically query the database for data, or to update something, or to delete something, whatever the command is here. This web API basically is the interface or the facade that converts requests from the app into requests for the database at the end of the day. And this is it's pretty simple architecture here, but that's all this app really requires. And this web API will be hosted in AWS, either through like a virtual machine, that could be Windows, Linux, or whatever. This web API could be built with PHP, it could be built with Node and Express using JavaScript. It could be C# using like ASP.NET or .NET Core. It could be Java and Spring. It could be anything. This database can be a MySQL database. It could be a MongoDB database. It could be Postgres. Like, it could be any type of database, and that would also be hosted on AWS as well. This also may have a layer on top of it, like I said, within AWS to decide, like this can be Linux or Windows server. You know, it can be it's probably be a virtual machine. Instance, cloud instance. So that's the thing we get with AWS cloud service. We used to have literal physical machines. Now we use AWS, which is, you know, these Amazon web services, which basically they kind of handle the internals of what server things get put on, and they kind of give you sort of like abstraction to say, hey, I need a Windows virtual machine, or I need a Linux virtual machine, or whatever the case is, to host something on, which could be a web API, could be a database, could be whatever the case is that I need. And even with the databases, like they provide sort of a facade to just say, hey, I just need a database hooked up, and so can you help me out, help me out with that. And so yeah, that's another part of it. And so this is pretty much a simple architecture of how it would work. And then you may also have other things outside of Amazon Web Services. So let's say we have a payment system and payment platform, which may be completely outside of AWS, and we may pay them separately for this service. So let's say we, instead of search here, just say we have payment or something like that. I don't know. Just make it like that. This might actually come from here and go down here to a third party. So sometimes we integrate with third party services, which I'm going to have to do in this app to do the payment for the subscriptions. Like people sign up for the app and they need to subscribe to the app. And so they would basically use a platform like, example would be like Stripe, if you ever heard of that. And so I may need to do payments to make sure that people are paying for the app, and then I would sign up my credit card or bank account with this service, completely third-party service. But these are the times when you choose whether you want to build your own thing or whether you want to use a third party to save you time. Now, I'd have to pay them separately in addition to Amazon Web Services, but I may save a lot of time because I don't have to worry about the internal workings of like managing credit cards and payments and all that stuff. Like this will handle a lot for me. And so there could be other, like I may have like I eventually plan to do some AI stuff. So maybe like I use open AI to do some kind of cool stuff. That could be sitting like somewhere like right here, where maybe the app directly hits this. It just depends. Like sometimes I need an interface between to do some sort of logic to help. Sometimes I don't. Like sometimes I can go straight to the API directly. It just depends. Like, or sometimes I might have to literally it may be related to something here where I need the logic makes more sense to have here. It just depends on what your app needs to do and when it needs to do it or whatever the case is. And so that's how that should work. And then the other, so like moving forward from here. So what happens when your application, like you can set something like this and get to a lot of users with this pretty simple architecture. I've built apps that made plenty of money just using simple architecture like this. But at scale, when you get to these big companies and these millions of users, then you start to have problems when it's that you have to solve around the scale. And so what are some of the things you can do in an architecture, using this as an example to help you with the scale? So one thing that can happen is your database can start to run out of memory, out of space that it needs, like literal gigabyte or megabyte space that it needs to store these users. So there's like two things you can do here. You can vertically scale, what's called vertically scaling. You can add more resources here. Pay AWS to give you more resources on the database. Like instead of having 50 gigs of space, you can say give me 100, and you can say give me 200. But you still can have an issue with the number of connections being made to the database that it can handle, because it's still only a single database. And eventually your database can become slow because it has so much data in it, because you're just vertically scaling it up to like some insane amount. And it can start to cost an extreme amount of money. And so what ends up happening is, or what one of the optimizations that you can do is like clustering or horizontally scaling. And so you basically can make a copy of this database, make another copy of it like this way. And so you can basically kind of picture that as like a clustered database with multiple databases where it could be sharded. So like you could say, I want users with 1 through 10,000. I want them in one database, and the next 10,000 I want them in another one. The next 10,000, and this layer before AWS and some of these databases have you have the ability to set up where the query routing can be smartly routed to the right database shard, or these could just be literal like copies. Like sometimes you may decide to just have a single database. You don't have a crazy amount of data. You just have a lot, and you may decide to just these are just backups, just failover. Like if the first one fails, it's always getting copied to these two, and you just fall back to the next database if the first one fails. There's a lot of strategies you can set up to help you deal with the scale and the amount of requests you have coming in. And if you split these and shard these, then it's less weight on each individual database, and you can have redundancies. You can spin up more anytime you need to. You can take away some. You can have it smartly basically spin up as your application and need goes up and down. And then the other thing you can do in front of this is actually set up caching. So you could like have a cache here that basically for a lot of your popular operations, and I'm gonna move this. I'm trying to move this. Wait, it's not. Let's try to move that up there. So you can have a cache where you start going to the cache first with your SQL query data. And if the cache has it, then you get it from the cache. And this would be in-memory cache. So let's call it like in-memory cache. So it will just be literally like, instead of doing an expensive database operation, it would be like a keyed memory cache for certain queries. And some databases, I mean, they optimize themselves to sort of do this. But one further optimization is to use an in-memory cache like Redis or Memcache to sort of like, and so then here, if it's not in the cache, you can go, then the request can go to the database, and then it can actually populate the cache afterwards, so they can be getting from the cache again. And then here you would have some sort of invalidation, which means at some time period you would say, hey, this data in this cache is old and I need to refresh it. So if somebody asks for it, I need to go to the database and get the latest edition of that data in case it's changed or whatever. And so for new data that gets added to the database, then you would have to basically like skip the cache and just go straight to the data. But you wouldn't find it here, and you just go straight to the database. And of course, for inserts that you know are not in the cache, then it would just go straight to the database for stuff like that. So yeah, so that's kind of like one way to optimize. And then similarly, like with your virtual machines here, you can also do a similar process where where you can basically have a cluster also of these services. So like if these get too many hits and requests, we can horizontally scale them, because these services, these virtual machines and these APIs will start to build up. They'll start to use RAM on the machines they're on. They'll start to use memory on the machine. Well, yeah, memory RAM on the machines they're on, and they'll start to use processing power. And so like there's two options. You can vertically scale and just pay for more processors, pay for more processing power, pay for more RAM, for more just memory on the machine to handle the request and the stuff it has to do, that the code needs to do to the data it needs to have in runtime to do what it needs to do. Or you can vertically scale and keep these stateless in a way to where when requests come in, you can have something sitting here to basically route the request to the best server that has the most free resources. And so that will help kind of balance out the herd of data that's coming in when you have a lot of users using your app, and kind of help split it out. And then you can spin up services as the requests get more, and you can downscale as the requests go down, whatever the case is. So you can save money on your services by having like automatic horizontal scaling set up with AWS and with your virtual machines. And so there's a lot more you can do. It can get way more complicated. I'm kind of giving like a bootleg version of explaining some of this stuff. But I hope it makes sense to like a simple degree. For anybody that's just getting into this stuff. For somebody that does this stuff all the time, it's probably like super simple and elementary. But I think it's valuable to everyone to kind of think about this stuff sometimes, especially if you're trying to build apps on your own, and kind of like how you would eventually handle some issues that come up. So I hope this makes sense. I hope you enjoyed the video. Let me know if you have any questions, and let me know if you have anything you would add to this or take away from this. Appreciate the time, and see y'all in the next video.